Hi, I'm Sonny Alvestias, CTO in the gaming industry. Welcome to my podcast, aimed at software engineers, programmers, and computer scientists. In every episode, I'll put one of the best engineers working behind the scenes in the spotlight. Hi everyone, and welcome to a new episode. I was recently doing some research on modern ways of doing software development, and I came across MobProgramming. Basically, today I have the pleasure to welcome Woody Zuill, which is one of the originator of the concept, and is also the co-author of the book MobProgramming. Hi, Woody, and welcome here. It's a big pleasure to meet you today.
Oh, thank you, Sonny.
So I'd like to start with asking you the usual question I ask first is what brought you into software and computer science?
Oh, excellent question, because I think I followed sort of a typical route, but it started for me almost 40 years ago when I needed to buy some computers for a little company that I had where we did a lot of graphics work. And I could tell that the graphics was going to become computerized. I thought I'd better learn about computers. And I didn't know a lot about them. I used a few, but I bought these computers and they worked pretty well, but most of the software that I could buy for them didn't work very well. And I needed my software to be dependable. And I thought, well, maybe I can learn to write software. So I started attempting to write software. The computer, one of the computers I had was a typical, what you might consider a personal computer. And it had BASIC on it. And so I opened up the BASIC work environment, so to speak. It was just in a browser, or in a command window, and started writing software. And it took me about 2 or 3 months of just trying to learn stuff. I think the first thing I wrote at all was just a game that I already knew, a lot of people had on the computer, but that gave me an example to follow. What are the rules and how do you do it? And after a couple months, I was sort of learning to program, and I started writing software that I would need in the business that I had. So that's about it. I'm more or less self-taught. I guess I was 30 years old when I started learning. It was impossible for me to go to school because I had my business, and I've just recently been married, and I had to keep working, and I just didn't have a way couldn't find a block of time to go to school. So I pretty much taught myself. I even just found a couple weeks ago, I found the very first book that I bought on the topic. And it really brought back a lot of memories. In those days, you would just take some code somebody wrote and put it in a book or a magazine and type it in. You couldn't download stuff. There was no idea of downloading back in those days. So there you go.
So you were experimenting from the code you could get from the books. Were you just trying every possible combination, or how did you basically learn from the samples? You tested everything, or?
So the first application that I wanted to write for myself was to keep track of my business checking. Where you write checks and then they return them, and then you would input them in so you could keep track of a running total. And then at the end of the month, they send you this thing where you can call it balance your checkbook. So you can make sure you didn't make any errors, that all the deposits you made showed up in the bank, that all the checks you'd written showed up in the bank. Since I couldn't wait months and months to have some application written, what I instead would do was write something I could program every night for 3 to 4 hours, get home from work and program. And I figured if I could write something that I could use the next day, then I could make this self-sustaining, because each minute that I could save for my daily work gives me another minute that I could spend programming. So I figured if I could automate all the things that I do, what I really wanted to do was automate things like cameras and drawing applications and things like that. We had equipment I wanted to run. But I started out with this check register, and then I would, the first thing, there's really only 3 or 4 things you need to do to make this work. You have to have a way to input your data, which you can do at the keyboard. You have to have a way to output your data, which you could see on this tiny little screen that came on the computer, or you could put it to a printer. And then you need to have a way to manipulate that data. So you need to be able to save it to a disk so that you can read it back later. And, you're saving so that you don't have to re-enter data every time you want to use a thing. And then you need to be able to somehow, as I was saying, manipulate it by doing math on it. In this case, we're going to be keeping a running total, and that allows you to, subtract the checks and add the deposits. So I started out first knowing that I need to learn how to input the data. So I just merely followed some, instructions somebody had about how you put stuff into a program or into your application, and then how to review it, how to save it to disk, and then how to print it out. So it was really a very small progression, but it only took me maybe a month to write that software. It's very simple. Let's look at one other point you brought up, and that is testing. So in those days, I was the only developer, the only tester, the only what you might call a product owner nowadays, the person who understood the business rules. I was probably going to be the only one using this software. So I was, the whole world of this software was contained in one person. Nobody else would use it. So I had to learn how to make sure it was working correctly. And almost from the start, I started using what I came to call, and I think the industry called, test harnesses. So a test harness was a way, there was no easy, there was no unit testing environments in those days. What I would do is take a block of code, copy and paste it into what I would call a little harness that I could write some tests in there to prove that it would do all the operations I wanted to do. That was a lot of work, but it also gave me a safety net to know that I wasn't breaking things. Now, there was no redundancy testing, or there was no way to verify that everything that I did before was still working properly. So I had to, I did a lot of manual testing myself, but since I was the only one using it, I could pay a lot of attention while I was using it to see if the numbers were about correct. So yeah, this was, to me, that was just seemed like a natural way to do it. That way, each day I could deliver something and find out whether it was useful to me. And then the next night, I would know what I needed to write next by what I had been able to do that day. So I would say this, to me, this was a kind of a naturally an agile way to approach things. There was no agile in those days. So by the time agile software development became a thing in 2001, and I read that Agile Manifesto, I thought, well, this is really in line with the way I like to work anyways. Of course, by that time, I'd been reading about Scrum and reading about extreme programming. So, I was already learning about these things.
I see. And what happened next then? You just kept working on other systems that helped you in your daily life, or?
Yes. So I wrote little applications that helped with the business, and then I was able to start learning how to control. In those days, you could get, well, not in the 80s, I don't remember the 80s, but as far as this goes, but somewhere near the end of the 80s, you could buy little cameras and things like that can be controlled from a computer. So you just need to use that serial output plug and hook it up to the thing, and you could send it instructions. And I really wanted to learn how to do that because I wanted to learn how to run things like plotters and cutting machines and so on. So I just continued experimenting with it, learning everything I could as I went, buying books wherever I could and whenever I could to give me the info. And then along that time, I would say by the early, or I should say mid 80s, you were able to start logging on, I think it was the 80s, someone could correct me, to these bulletin boards using a modem. I don't know when that was, but I started doing that and learning a lot more because there were people there who could share information and show you what they were doing and share code. You could download things. So yeah, I just kept going. It was by, I'd say 1995 or 6, I realized that I was more interested in doing the programming than I was in the business that I had. And I thought maybe I could change my career to being a programmer. So I was programming 3 to 6 hours every day. And then I thought, it's got to go beyond that. And I started checking out doing work for other people and started doing that in 1996. People would bring things to me and I'd write the code for them. Really simple stuff mostly, but a lot of people were trying to get custom software, and so I started learning to do that. By 1998, I started switching my career. And by the beginning of 1999, I was full-time programming in companies for other people.
What kind of operating system was there at that time?
That was called CPM.
Oh, okay. Never heard about it.
That stands for Control Program / Monitor. So CPM. It was an Osborne computer. In those days, you could buy what they called a luggable computer, or people nicknamed it luggable. It was a computer that had the keyboard attached to it, and it was about the box the size of a sewing machine or something like that. You unlatch the front, you lower down the keyboard. It's got a little screen that's about the size of a typical modern smartphone screen. And there you go. That's all contained in one thing. It had two 160K floppy drives. And matter of fact, I still have a box of those old floppy drives that I'm just getting rid of. Yeah, I'm going through all this old junk, and this goes back, this is 82 or 83. I think it must have been 83 that I bought that computer. CPM operating system was a very straightforward, simple operating system that was for the, I think, like for the 8080 chip and similar chips. And it actually worked extremely well. And that was from Digital Research. And I believe that is basically what MS-DOS was patterned after. So yeah, I learned on that on an Osborne computer, which I just should have looked up while we were talking about it. I'm going to look up when that was. Osborne computer one. Yeah, because I bought it the year they went out of business. And I think they went out of business in 1983. So I could look that up and actually then know when I started programming. Even though I was reading about it and looking at it and trying it out on various little computers some friends had, I didn't really in earnest start, it looks like, until 1983. Yeah, it was discontinued in 1983. An interesting side note, Osborne basically put themselves out of business. What they had done was they had these very capable computers, but they announced a new computer that they were making that was going to be a lot better. So everybody stopped buying their current computer, waiting for the new one to come out, and they lost their stream of income. So that's the way I understand it. I think it's called the Osborne effect. The Osborne effect is a social phenomena of customers canceling or deferring orders for the current, soon-to-be obsolete product as an unexpected drawback of a company's announcing a future product prematurely. So, yeah, that's sad, but that's life.
Yeah, that's a good lesson to learn, definitely, yeah. I've never heard about it. Yeah, it's really interesting.
Yeah, maybe so.
I mean, it was bad for them, right? But yeah, good lesson for everybody, I guess.
Yeah, well, we don't know the problems that might happen. Sometimes we learn from failure, and sometimes the failure closes us down. But regardless, the rest of us maybe will learn from someone else's failure. One of my maxims that I follow for myself is to pay attention to what others are doing, whatever they're doing in software development, and then attempt to use anything that looks possibly helpful and learn for myself from their example. And if they made mistakes, hopefully they've done a podcast or a blog article or something about it, and I can learn from them. But I always like to try things. I'll try anything new that comes along as much as I can, so I can see, like, for example, with pair programming. When I first heard of pair programming, I was old enough to know that it's probably going to be a good thing. When I was younger, I probably would have said, well, that can't work. You got one little monitor, you got a keyboard, how can you have two people doing this? And so, but by the time pair programming came out as something to try, the people who were talking about it are people I respected. And I thought, I should give this a try. Rather than saying, I don't see how that could work, I tried it in earnest. And I actually tried it for almost 2 years, trying to get people to work with me with it before I decided that's how I want to work. So it's, sometimes it doesn't take a day or two. You can't try something like pair programming for a day and then say, oh, that's not going to work for me. Well, you might need to build some skills. You might need to learn something different about the way you're working, or learn something different about yourself. And that will lead you to becoming good enough to use this practice that you currently don't think will work.
Yeah, I agree. I definitely agree.
All of the work that we do, even when we're working alone, is in some form of collaboration. In other words, we're not just sitting there alone, unless we are, like when I originally started programming, using my only writing software for myself and using only my own knowledge and only my own abilities. I don't have anybody I can turn to ask questions. In that case, there's not much of a collaboration. But anything in modern software development, if we're writing software other people are going to use, it implies there's a collaboration, at least between the person writing the code and the end user of that code. The question is going to become, how effective do we want to make that collaboration? If we use collaboration mechanisms that do not include some form of rapid feedback, our collaborations are going to be very weak. If we don't involve people in direct conversation or directly sitting together in front of a computer to show them things and talk about it, then we're using a worse form of collaboration. So we want to find what's the best way for us to collaborate. And it doesn't mean we have to use that form all the time. It just means that it's another option we can use. Rapid feedback, I think, is extremely important. So that's why I think pair programming is so effective, is because we can get rapid feedback from at least one other person. And there's a lot more to it than just that.
Right. So you, like, as I said in my intro, you are famously known for this concept of mob programming. So was it pair programming that kind of gave you the idea and the team at your company at that time, or?
Yeah, I think it's a long process. So I started learning about pair programming, I think, in 1998. By 2002, I was looking for every opportunity to work doing pair programming. Now, we didn't, originate the idea of mob programming until 2011. So during that period, I was experimenting a lot with various styles of collaboration, not just in writing code, but in all the work that we would do. I would notice, for example, if there's a documentation writer in a company and they're going to document all the work for end users or for whatever purpose, for support, whatever it might be, that person would usually come and interview some developers and then go off and write that stuff alone. And then we'd have to read it and edit it and so on. And it became clear to me that if we just sat together and wrote that document together, that's a higher form of collaboration. But this all started for me, I think, in 1999, where I went to work for a company and I was put on a team. And yet the team didn't do anything that I could recognize as teamwork. Their work was all solo. And they would sit in the same general area, in some cases in the same room at their separate computers, and they would all be working solo. So they would spend some time breaking the work apart, and someone would say, I'll work on this module, someone else will work on that module, and then they sit and work alone. And I thought, well, why are they calling this a team? Because if you think of a team like a sports team, you're all playing in the same game together. Now, you're not playing the same position, but you're all, for example, in a baseball game, in American baseball, you're going to have a first baseman, you're going to have a pitcher, you're going to have outfielders, you're going to have these different positions being played, but you're all playing in the same game and you have to interact really closely or you will lose the game. So I didn't see anything like teamwork, and I started wondering, why aren't we doing teamwork? And I started looking for examples of teamwork. And so pair programming, of course, is a style of teamwork. And I got really enthused about that. And as I went on, I started experimenting with, well, what if I team up with a tester? What if I team up with a business analyst or a product owner, so to speak? And we sit together at the computer. And then sometimes I would do it with three people. There would be the developer, a tester, and a product owner, or a business analyst, we called them. So as that went on, by 2005 or 6, we were doing learning sessions where there would be 5 or 6 people in the room, and we're all studying the same thing together, and we're all sitting at the same computer. Mostly what we were doing is switching out the pair. So there'd be one pair working at the computer and everybody else interjecting stuff or helping a little bit. And then every now and then we'd switch out the pair. And so someone else would sit at the computer and someone else would be what I call a navigator. And that was pair programming, but done with a group. And so then in 2011, I joined a company where the team was not very effective, and they wanted somebody to manage this team into being effective. Conceptually, mob programming is more than 2 people, I guess, working at the same computer at the same time on the same code. In those days, we'd be sitting at the same place. Nowadays, we're doing it remotely a lot because of the pandemic and things like that are affecting us. So there you go. In 2011, all this stuff kind of came together with a team where we were studying together using a group study practice called a coding dojo, where we would work on some exercise together for 3 or 4 hours, could be more than one exercise. And we would rotate the pair, and we were getting good over a 6-month period. We were getting good at letting each other speak and following other people's direction, do what they've asked us to do, sharing ideas clearly and succinctly and finding ways to share those ideas. And we were practicing this for almost 6 months. And then one day, one of the developers came to me and said, "Hey, I've got this program that I'm writing that's got a lot of problems that I need help with it." And so we all gathered together in a room. We took a look at it. And instead of just looking at it, we started working on it as a team. That first day was in, I think, October in 2011. At the end of that session, which was a 2-hour session, we all felt this was highly effective. And we decided to go because somebody came into our meeting room where we had reserved a meeting room, and somebody came in and says, "Hey, you're going to need to leave because we've got this meeting room reserved." So we found another open meeting room in the company and went over to that, and we kept working as a team for the rest of the day. And at the end of the day, we do this thing I call a retrospective. At the end of every day, we would look at what we did that day, talk about what went well, and decide how we will get more of that good. I call that turn up the good. At the end of the day, we did that retrospective. We decided that to turn up the good, this is basically what we saw. What went well today? And this is what the people in the team said. We got a lot done. It was a very high quality. We were learning a lot, and it was fun. Now, any one of those things is interesting enough to me to want to try it again. Let's see how that works. And let's see if this was a fluke, or can we get better at it maybe? So we all decided, I would ask them, well, how do we get more of that? How do we turn up the good on this? And everybody said, well, why don't we just reserve some rooms tomorrow and work this way tomorrow? So we did. And we literally continued working that way even up until this day. Our basic rule was that we can work as a team anytime we want to, or we can work solo, or we can work as pairs. But over just a few weeks, we started working more and more as a team, and we would reserve rooms. And after a couple weeks, we decided we need to have a permanent room, and we found a permanent room. So there's the story of how mob programming started in a nutshell. It was a team that was exploring, more or less, exploring how to work well together, how to turn up the good on collaboration. And we landed on this idea that we ended up kind of as a joke calling, not even kind of, it was a joke, calling mob program. Mob programming is working as a team without chaos, without people interrupting each other, being respectful, being kind to each other. So it's not like a mob where we're an angry mob. We're a gentle mob. We're a gentle group of people trying to work well together.
That's really interesting. So to be honest, that's something I've never experienced yet, but I'm really keen on trying it as soon as I can. I've experienced with pair programming, and I think it really does sound like a better, even better experience. Yeah.
Now the skills of pair programming pretty much, are the same that you would need to do mob programming, but a lot of people do pair programming in a very ineffective manner. And in 2009, before we conceptualized this idea of mob programming, I worked with a fellow for a couple weeks. I had a couple weeks free, and I wanted to work on some. I don't even know if it was a couple weeks, but I wanted to work on some open source stuff. And this was a friend of mine. His name's Llewellyn Falco. He'd be a good one to do a podcast with sometime if you haven't done it yet. I contacted him and he said, "Yeah, I got some projects I'm working on, open source. So come on down." And we sat together and we did pair programming. He won't work without a pair, and he won't work without test-driven development, which are also my basic guidelines for myself. So we started working together. What I noticed was he explained what he wanted to do, what it was we wanted to do with this project. And then he went to the whiteboard and diagrammed it a little bit. And there were three main stages. One was we're going to extract out an interface for a part of an existing class of code. And then we're going to implement the current implementation that's in the original code. And we're going to do that in a new class that implements that interface. If you don't understand what that stuff is, any coders out there, if you don't understand what that is, it's not a big deal. But the basic idea is we're going to start making a new class or a new chunk of code that contains the original functionality. Then we're going to write the new functionality in a new class implementing that same interface so that this code can be used interchangeably. If a programmer who's using the code decides they want to use the new way, they can do that, or the old way, they can do that. So he explained that, and then I thought he was going to sit at the keyboard and start typing away. But he didn't. He said, could you go ahead and extract out the interface? And so I said, sure, because I know how to do that. I started doing it. And while I was doing that, he was paying attention to what I was doing, but he was also thinking about what's the next steps. How are we going to move the code into the new class that's going to implement the existing functionality? I hope that wasn't too boring for people, but the basic idea is we were collaborating with me paying attention to the detail of the current little bit of work we're doing. And Llewellyn, that was his name, Llewellyn Falco, paying attention to the what's next, like what's down the road. Like when you're driving with somebody in the car and they're navigating you to go pick up a friend, let's say. They're saying about 3 blocks, we're going to make a right turn. So the person driving can go those 3 blocks. And they can even ask, is this next one the right place? And they'll say, yeah. And so you make that right turn. They say, go about a mile and then make a left turn. And so as we guide each other working this way, we are dividing up the work. One person's paying attention to the detail and the other person is paying attention to where we're going immediately next. And as we do this, we are both getting a full understanding of what we're doing. And at any point, if we feel that we don't really know where to go, we can have conversations. We can, as the two together, can talk about it. But the key here is that the person with the idea is not sitting at the keyboard. So once we come up with an idea, that person becomes what we would call the navigator. And the other person, the typist, stays at the keyboard, and I would call that the driver. So the driver and the navigator are working together with an expanded brain and able to work on 2 different levels of this code, the detail and the slightly less detail area. It really worked well. And after a couple hours, I had asked Llewellyn, well, I've worked this way before, but I never really did it formally. I really like it. Can you tell me more about it? And he said, well, I follow this one simple guideline. And it was simply this. For an idea to get into the computer, it must go through the hands of someone else. So this forces us to have a real collaboration where we're sharing our ideas. Whereas when we pair program without that, and when the person with the idea takes the keyboard, now we have a less communicative manner. We're going to see some code being written, but we might find it difficult to follow what's the bigger idea. And this just makes it real easy and straightforward to follow that. Now, there's a lot more to it, but that's the basic idea. So once I learned that in 2009, that became my preferred way to work. And by 2011, that was pretty much the only way I was actually writing code whenever possible. We use that same concept as we use the coding dojos in our learning sessions. We did weekly learning sessions of 3 hours or 4 hours every Friday, and it worked really well. We were adopting it for our pair programming practices. Then that just naturally moved itself into mob programming because it works so well. I want to interject one other thing. There is no rule of mob programming that you have to do this. That's up to the individual team to decide how they are going to work. I don't really have any strict rules. Mob programming could be maybe really condensed into this. Let's learn how to collaborate really well, and whatever it takes to do that as a team. That's mob programming.
Would you still have some kind of like advices or tips, some faux pas to avoid for a team that would like to try?
Yeah, certainly. Now, I've done hundreds of workshops. I tried to count it the other day. It's hundreds and hundreds of workshops. So I've got a lot of experience helping people learn how to do this. A couple, what I would consider anti-patterns, are when the person has an idea and they would prefer to take the keyboard to show that idea. That's okay. But if we get good at explaining our ideas without having to be at the keyboard and guiding someone else to key it in, that's a skill we want to learn. So let's make sure we do that, when we can. After a while, some people become really good at it. And most of the teams I've worked with who become really good at it, they get a much higher level of collaboration. Another thing is always try everybody's ideas. So if 2 people have opposing ideas, let's try both of them. This frees us or gives us the freedom to share our ideas without fear. Because what a lot of people do when they, if somebody were to say, oh, I know how to do this, let's extract out an interface and blah, 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 whatever they're going to do. And someone else says, no, that won't work. And here's why. That kind of stunts our desire, or that shuts off our desire to share our ideas. If we're willing to try every idea that comes forward, we'll become good at trying ideas quickly. I've seen programmers argue or talk about which ideas they should try for a half hour or an hour before they even try anything, where they could have tried 2 or 3 ideas in that half hour or hour. So I think that we don't get as much learning by just discussing. We get a lot more learning by quickly getting something into code and seeing how it works. That doesn't mean it's going to be our final solution. It just means that's a very fertile learning environment to go to the code and to actually try it. So there's a couple things. Another one is somebody who leads all the time. So if there's only one person guiding the process all the time, that's an anti-pattern. And I would suggest if you're going to learn to do this, make sure that it's not one person monopolizing all the guiding of the process. So I would say it's rare on a full team. Now, a full team that's mob programming, you can consider a cross-functional team. You might have a couple coders, a tester, a product owner or a product expert, a database expert, and some other people like a deployment expert all on the team working together at the same time. So no one person is going to have all the knowledge needed anyways. We have to make sure that the people with the knowledge are the ones guiding the process. That means when some database work comes up, the database expert is guiding that process with other people at the keyboard. We have some front-end code to write, same story. The front-end expert will be guiding the others in writing that code. Now that seems difficult, but we found it to be really straightforward. We all learn as programmers and technical workers how to use all sorts of environments. It's not as hard as it seems. It actually becomes pretty easy after a while with other experts guiding us.
Does that mean that during a session of mob programming, we could go through several code base, like different projects? Because like you said, maybe there's a database or a backend guy involved, and maybe a front end guy, maybe it's a different code base, right?
Yeah. So typically when we're doing this, we divide the work up, and then some database person at some point is writing some database stuff, and a front end person's writing some front end stuff, and a back end person's writing some back end stuff. Then we need to merge these ideas and put them all together. So basically this is the concept, people call this being in a silo. The database person is always focused on database work, so they're in the silo of knowledge of the database area. But this also gives them, they're also in, I would say, a silo of ignorance. They don't have much knowledge of how their work affects the rest of the project. When we work as a team, we start getting rid of those silos. We start getting an understanding of how my code affects other people and how their code affects me. And as we get good at that, we become better so think of it this way. If as an individual, you could know all that stuff, that would be really a great way to create software, but we can't have all the knowledge inside one person. It's very rare that you don't have to go out and ask somebody else to do something or ask somebody else for clarification on something or whatever. If we bring all of that together on one team where we're interacting and working at the same time, we've basically created something like a superhuman with many brains. This is not isolated to software development. As a matter of fact, part of what it surprised me, working in other companies was how little real teamwork they were doing, as I said earlier, and yet how much in other kinds of work people were doing tight collaboration where they were working together all the time. I've talked to scientists working in chemistry, making adhesives, and they explained to me how they work basically the same way. They all work in the same room with one table where all their equipment is. They have their individual computers, but they're always doing these experiments a lot of times together. This particular company that I talked with. And I've noticed it many places. And you can think of it in a more general way, like an orchestra or a music band, like a rock and roll band. These are people collaborating together at the same time in the same space, doing the same thing, but they're all bringing their own individual genius to the process.
Earlier, you mentioned by default, you go with that way of developing software. Is like TDD somehow some kind of like the best companion of mob programming, or?
Well, that's a very good question because it brings up the idea of I don't think there's such a thing as a best, practices. So I like test-driven development. And actually, I'd learned, over the years that when I don't do test-driven development, I end up creating problems for myself. So how do I keep from creating those problems? If I have unit tests in place where I can do regression tests, but I can also use it to develop and design my code that's combined together. That gives me a really powerful way of working. When we do mob programming, it seems a natural fit. So I wouldn't insist on it that your team or somebody else's team has to do this, but I feel it's certainly a good companion. These do fit nicely together. Mob programming, pair programming, solo programming all benefit from test-driven development. But when we're working as a team with 5 or 6 people interjecting things, it's hard to know if something we're doing over here is breaking something over there, as it can be when we're solo and we try to isolate things best we can. So with a team, it's so much easier if we're doing test-driven development, in my own opinion. But I'm not suggesting everybody has to do that. I want to make that clear over and over here, I guess. This is about figuring out what works best for your team, but it certainly has worked well for me and the teams I've worked with.
Right. I was also wondering about continuous delivery, because it does sound that like everything somehow that is produced during a programming session sounds like it should be shippable, right?
I would argue yes, but that's again up to the team doing the work. So if you cannot deploy daily or several times a day, or get your code into such a state that you could check it in and deploy it if necessary, then I think that we're losing the benefit of being able to verify that our code is working properly in the real world. So if you remember, when I first started programming, whatever I wrote tonight, I wanted to be able to use tomorrow. And as I learned to become sophisticated with that, in those days, it was pretty straightforward. Nowadays, it's quite a much bigger thing, especially if you're delivering your software to the world, to the internet, or whatever. So, if it's directly being deployed immediately to customers, you have to be pretty sophisticated about being able to automatically roll back if there's a problem and so on, and be able to test fully on an hour-to-hour basis or a moment-to-moment basis. I would argue we can do that, or I would suggest that we can do that. And it certainly is helpful to this model of working to be able to deploy instantly at any time. A lot of teams I know of that are doing mob programming have that capability, and I think it accentuates our ability to get rapid feedback. It's a funny thing with software. We could be working diligently on one thing, deploy it, get into the customer's hands, and then it's necessary to work on something else. So if we had to wait until we had completed all the work that one customer or one application needed before we deployed it, that could be a long, long time. We want to get this into people's hands so they can get the benefits of it sooner if we can. And that's one of the benefits of being able to deploy just about any time. And in my original model where I was talking about my checking account thing, I was able to start using it to record data very shortly after the first deployment or second deployment. I could start inputting checks and saving them to the disk, but I couldn't do much with them. So I had to, write the other parts, but at least I was able to start doing some of the work almost immediately. So yeah, I think continuous deployment, continuous integration, continuous development, all those things, if we can deploy immediately, that's a big benefit.
Okay. On another side, I was also kind of like wondering, is there a relationship between mob programming and agile methodology, like Scrum or Kanban? Is there one that works best with mob programming?
Yeah. So I learned extreme programming first as I was trying to discover these things back in the late 90s, and came upon Scrum and started reading that and read all the articles I could find on it. And then whatever got published, I would read about Agile stuff, because when the Agile Manifesto came out in 2001, it really suited my way of thinking and the things I was already trying to do. But I kind of look at all those practices, extreme programming, Scrum, Kanban, not practices, but sort of combined practices into methodologies as being stepping stones. If you learn a methodology and then just continue using that methodology exactly as you learned it, then we probably aren't getting the benefit of the biggest advantage of working in an agile manner. And that benefit comes from reviewing and reflecting on how things are going. So a lot of those mechanisms ask us to do regular reflection or retrospectives. And if we're doing them every month or every 2 weeks, that's good. But if we're not making changes to our methodology as we go, then we're really not getting the benefit of it. And I would say it this way. If we are doing something like, let's use Scrum as an example, Scrum, and we're doing it exactly as we learned it 2 years ago, I think we're missing out on the main advantage of Scrum. And that's they call, I think, inspect and adapt. If we aren't growing our mechanism, there's no one size fits all. So in our organization and with our team, we need to learn how to move past that. So we have to become the innovators of our process. We cannot just follow what someone else told us works. I've been at companies where the management insists that if one team is doing really well, they want everyone else to work just like that one team. That probably is good for experimenting, but it's not necessarily the way things should be. So I would say if there's any best practice, it's that we should be constantly reviewing and changing our practices. I see agile, extreme programming, Kanban, all of these things, Scrum, as being we're using a collection of practices that are ever evolving. So the practices themselves are evolving, and the practices that we are using might evolve. In other words, we might change from one practice completely to another practice. So if we're used to solo programming and we introduce pair programming, then we now have both options and we can use both. We might find we prefer pair programming, which I do. And so we will maybe not solo program as much. Now, I really love to solo program. I love to work alone. I actually get a lot of enjoyment out of solving problems on my own. But that doesn't necessarily suit the business environment where we're trying to get things done directly and quickly. So we could be doing mob programming and Scrum. We could be doing mob programming and Kanban. We could do mob programming and working within a more or less extreme programming approach. There's no reason we can't. But I think we'll find that as we get better and better at deploying quickly, there's less need to plan what are we going to do over the next 2 weeks, which moves us from a Scrum model into maybe more of a Kanban model, which means we're only going to pick on a little bit of limited work, get that work done, deploy it, and then pick the next work to do. I want to give a practical example where we originated this idea. We were delivering software to all the departments in the company because our team was the custom software department. Anybody or a team, anybody in the company who needed software would come to us to write the software they needed that they couldn't buy directly on the market. So this would be custom, has to be custom written. And that meant we were often working on 5, 6, 7 projects, even more at a time. And because we want to deliver regularly to each department or on each project or each product that we're working on, we would find that we could do this doing mob programming. We could work on one feature for one product, get it done in 3 hours or 4 or 5 hours, or let's say a day, deploy it, let them start using it and giving any feedback, and start on another project's feature, some other product's feature. And then we would work on that till it was done. And then if the other people were ready for us to continue on, we would, or we would pick up another feature for another project. And we would break the features down into as small a size as possible, which does not require any estimates. People will argue, well, you need to estimate how small things are. But I think all you need to do is get good at breaking things down. Then when something's broken down and you can't break it down any further and still be delivering something that you think will be of value, of course, that's kind of an estimate of itself. We think this will be of value. Then we can work on it. We might learn in working on it that, boy, this is bigger than we thought, and we can break it down further. You can certainly work on several things at a time. You can also, I would say, working on a Scrum manner, Kanban, extreme programming. Find the practices that work for you. Find the mechanisms that work for you. Try them, learn about them, experiment with them, inspect and adapt.
Right. Okay. Yeah. At what stage of a software development cycle does mob programming start, and when does it end, if it ends? Like, can we?
Yeah, please finish. Yeah.
Do it straight away, or can we do it straight away from the inception of a project up to the deployment, or?
I believe that would be a great approach. In other words, as soon as somebody somewhere says, hey, we need some software for this, that's the time to start working as a team. In other words, if we think we need to complete our idea before we can start working with other people, I think we're missing out on the teamwork that can happen at the beginning of the process. We really are working as a team, or I should say we're working on this in a collaborative manner if we do that thinking alone, because we are using input that we've already got from our developers or the other people involved from other projects and so on. But if the longer we do that, the less we are going to get the benefit of continuous integration of ideas. So I think a lot of places the business decides, so the business people decide what software do we need, and they pretty much bring it to a very full description before they go and involve developers. And at that point, maybe they want to expand on a little bit, do some requirements documents, come up with some initial estimates. And a lot of that is losing out on, so that means the process before we've even started documenting all this could have benefited from more people being involved. And I would argue this, as soon as we have an idea, then we can start development of it. And that the development process itself will guide us into what do we really want to do with this. And this is one of the biggest advantages of working in an agile manner. I had some great experiences with this, but in 2003, I believe it was 2003, I took on a challenge to work on a project that was really failing. And the main developer or the developer on it had quit, and the company didn't know what to do. So they called me, and I came in and looked at what they had. They had like a 80-page requirements document. The application was not working at all. It was adding a feature or a number of features to an existing application. And nobody could use the new features that they were working on because the whole application was not really working anymore. They were needing to use the earlier version of the application. This went on for like a year. And finally, the person who was doing the work quit because it was such a nightmare. And they brought me in and I said, look, let's revert back to the first day. Let's pick one of these features that you really want the most, and let's work on that for a week and see what we can deliver. Now, remember, this was almost 20 years ago. We did that, and we deployed something within a week. It was a very simple version of one of the features they wanted, and they liked it. Now, this is the big benefit of Agile. From that, they were able to decide what do they want next. And they start getting used to the idea that we can be using the ideas we want in the software sooner if we just do one at a time and deploy it every time we get something done. So we got a regular weekly deployment with that for about 4 weeks. And after we delivered the third feature, I went to the main people involved and said, well, what do we want to do next? And they said, well, actually, those 3 features out of the about 50 that they wanted, they said, boy, those are really helping us a lot. But now we have a new idea we want to add. This is so much better. I hope everybody can see that. It allowed us to not do a bunch of work. We could discover what was important to us and not have to do the stuff that we thought was important to us. And this is a maxim that I made up for myself. It's in the doing of the work. It is in the doing of the work that we discover the work that we must do. Now, that to me is a really, really powerful concept. It's in the doing of the work that we will get the insights we need to discover what it is we really want to do. If we think we can imagine all the features we want up front and then just deliver them, in one big chunk after a year, I think we're losing out on this discovery process. So Agile itself, I think, is mostly a discovery process. We're going to discover what software we want, what's the best features to deliver right now, and we will learn from it. Sometimes we deliver a feature and nobody likes it, but now we know that we need to change it so we can collaborate with the users. What would you want to have different? And we can do this in a very rapid turnaround. I think it's extremely powerful. There we go. That to me is what Agile is. It gives us this ability to learn about our work, learn about the product, learn what's best, instead of trying to figure that up ahead of time when we know the least about what we want.
Okay. Yeah. So basically start mob programming anytime that we have like a product statement, that the main requirement, I would say, and then just keep working on it.
That's a good way to say it. Yeah. If you say we need a reporting system that will help us forecast our production line, if you know you need that and you're currently doing it manually, You don't need to document everything. All you need to do is say, that's what we want to automate this, and we can just start on it. If it's a completely new idea, we can just say, hey, we have this new idea. I like to think of it this way. If we come up with an idea, why not try it as soon as possible? If we come up with an idea, we can learn by trying it sooner. Well, how can we go about doing that? Let's find a mechanism for doing that. Prototypes are okay, but if they're not doing real work, we're not going to get the full learning. And I think prototypes are great. I've done dozens, if not hundreds of prototypes. With software, sometimes a prototype can easily turn into the real project or the real product of our code. So we live in we're very fortunate in software that we can do that.
As you mentioned earlier, we're living in an era where there is a pandemic, right? So more and more companies they switch to remote work. So you mentioned that mob programming is compatible with remote work. Is there any advice you could give to a team, let's say that would have different time zones, or any specifics of working remote? I would say
being remote merely means we're not sitting together. So, for example, when we first had a need to have a remote worker at the place we originated this idea, we actually spent time practicing that while we were in the same space. So in other words, there was a person who's going to need to work from home for a while. They just moved to a different workstation away from the team, and we practiced the techniques that we would need to have to work remotely. But we could easily just stand up, walk over to the other work area and say, oh, this isn't working, or we need to change this or whatever. If we weren't able to, the tools we were using weren't working very well. So what we learned over time was you need to have an easy way to share the screen. And there are many ways to do that. Some applications like Zoom and others allow you to give control of your screen to someone else, and they can be typing at your screen while they're sitting at their screen. There are other mechanisms. For example, you can have a remote server that everybody can log into the same instance and all have access to this work area. Now, these things can be difficult. It's a little more difficult than when we're sitting at the same computer physically. But a lot of us have now been working for a year and a half almost, fully remote doing mob programming, and it's not that big of a deal. I would say experiment with it and work out those issues. The coding itself can be done. There's a website somebody put together called remotemobprogramming.org, I believe. You might want to check that and then put that in the show notes or something. There's this concept they had of somebody opens up the environment on their own computer and shares their screen view. They check out the code. They work on it as the driver while other people are guiding them. And then they check the code in when the next person takes over the keyboard, which is the way we would typically work with mob programming is we used a timer to rotate the person at the keyboard. So not everybody's at the keyboard at the same time. In other words, it's not just one person at the keyboard the whole time, but you can do one person at the keyboard the whole time. You can rotate it in any mechanism you want. You can use a timer or whatever. So you just need to modify things a little bit. I think there's advantages to working remotely, and there's advantages to working all together in the same space. One area that I find a little difficult working remotely has been having a really effective whiteboard, a place where we can share ideas and talk about our ideas. I think a whiteboard is really critical when working with a team or some mechanism for getting our ideas temporarily down in an area where we can point at things and move things around and talk about it. It helps us stay on track. I haven't found any way of doing that yet that works as good as when we're sitting together at a physical whiteboard. But other than that, you'll work out the details. You just need to get good at sharing whoever's at the keyboard and guiding that person. You have to be good at letting each other have their say. It's a little different than when you're all sitting in the same room. It's a little different because the way most remote screen sharing and meeting software works. But you practice it and you'll get good at it. It's not that difficult. Like I said, we've been doing it for a year and a half, and many teams have been doing it for way before that. People like at Cucumber.io have been working with mob programming remotely for years. The time zones is a problem. Like if you've got somebody that's 5 time zones away from you, that's, you need to find that block of time where you can work together. I did some training years ago, 2006 or 7 or something like that, with some groups in China their time zone, we could only align at the very end of my day, at the very beginning of their day, or whatever, and we could do, we have a window of opportunity. But yeah, time zones can be a big problem. So the further apart you are, the more difficult it can be. But there's no reason you can't, at least if you can find an hour or two, you can work together, collaborate, doing mob programming for that hour or two.
Right, right. Thank you for all this good advice. Okay. In like websites or mobile apps development or even games, because I'm in the game industry, we're often waiting on UI UX mockups to be like kind of like finalized or approved right before jumping into coding. Would you also say that at some point the mob programming session should be pending this validation before jumping on the code? Is this the same situation, or?
I would like to see that the people who are doing the UX design, the people that are doing the mock-ups and all that you're talking about, they're really part of the development team. If there is a way to work more closely with them as a team and to work in much smaller steps, I think that it's commonly believed that that work has to be done ahead of time before we can actually start on it. But I don't think it needs to be. I think that we could, that's an area of our industry we really need to reinvent, is why do we feel that work has to be, is it, if it's really unique and we've never done this stuff before, like it's a completely new game concept, then, or whatever it happens to be, then, you might want to do a little bit more prototyping and conceptualizing before you go to the production code. But if our process is so rigid that, if we start writing code and then we have to rewrite it completely as we finalize things, I would be surprised. I haven't seen much of that. So if we have somebody who's needing to make a lot of digital assets, that clearly might be done on a different thread, or a different done in parallel or whatever. But they certainly don't have to have all the digital assets done before you start writing the game software. The team isn't necessarily also going to do everything that supports them as a team. For example, just to really make it ludicrous, I guess, we're not going to necessarily buy a catering truck that the whole team will use to make our lunches. We might just have the catering trucks show up and provide the food, set it all up, and we eat the food. What do we consider part of the work of development? There's going to be some things that are sort of on the periphery. But in the old days, I used to see people wanting to design the entire database before the application is written and things like that. And I think that was very harmful to the process of figuring out what's the best way to do things. What's going to be best for this project or for this product.
I don't know if you've seen it, but GitHub, they recently beta launched, I think, something called CoPilot.
Oh, cool.
If I remember. So it's basically some kind of AI that would, I would say maybe it's like a navigator, but that would somehow complete your code. So you could just like type the name of a function and it could like autocomplete the entire function. Would you think that there's somehow a future of AI into a mob? Would you see like a place for AI in a mob programming?
Oh, sure, certainly. So, like our typical environments where we're writing, our development environments where we have, code completion and all that, it won't necessarily. So AI will probably never know how to write the guts of the function without a lot of information from a human, because what do we want it to do? We need to communicate somehow. If we can't, if we could just say, oh, I want a game that works really well and everybody will love, and it's a lot of fun and we'll make a lot of money on, and then you press a button and the AI or whatever creates that game, that's fantastic. But what we're really talking about is moving to a slightly more capable development environment. So where I started in BASIC, you wrote all your code. And then somewhere, you could copy and paste things, but there were development environments. As those started becoming available, like for BASIC, they came up with Visual Basic. And they started having, an environment where it could do some code completion for you and so on. That just is making it easier and easier for the people who are creating the software to get their work done. And, the original programming, like when I was in school, in high school, they had some little computer thing, just like a hobbyist computer thing, where you would flip some switches to create an instruction. Then you would hit a button and it would put that into a register or something like that. It would store that instruction. Then you would put in another instruction. It would store an instruction. They were very simple instructions, like take this value and put it in this memory location. And then take this value, put it in this memory location. And then another instruction is add those two together and put the result in this location. Well, that's a very tedious way of working. I never did work, doing things like writing code in these primitive environments. But again, over time, the environments become much more capable. There was a time when just dragging and dropping things became very easy, so we could create a lot of software very simply that way. So in some ways, I would say this probably has some of that capability. It sounds like this is just a code completion. Is it to actually write functions for you where it will do what you ask it to do? Or does it just simply write the framework for that?
So I haven't tried it personally, but from what I've seen, it would kind of like guess the content of the functions also.
So you would have to have some way to tell it what that content would be.
Yeah. So it's like you have to give it a proper name to the function, then it can guess. And I think it's based on they've done a lot of machine learning on all the code, open source code they have, just to have this function of being able to guess content of functions. And I don't know how useful it is and what's the extent of it, but it sounded like pretty neat, I would say.
So I would say there's no reason not to explore it and even to try it. And trying it is probably the only way to get to know it. It doesn't matter, mob programming, solo programming, pair programming, whatever. Anything you can use that helps you learn, it helps you do a better job, and so on. It's worth exploring. It certainly looks like this would be worth exploring. This is not something that you just automatically can do necessarily. I've worked with a number of teams, training teams, and you have to build some skills to do this. So realizing there are skills you need to have to be able to do this is a very important part of learning about it. So you need to learn how to work with others, which means you need to learn how to share your ideas, try other people's ideas, dig into ideas as a group. So we're all solo programmers, most of us. The first few years of our programming life are spent alone. I programmed 15 years alone before I ever heard of pair programming. So we need to realize that this isn't something you're going to try once and say, okay, now I don't like it because it doesn't work, or I really like this, it's great. I think you need to use it for a while, get good at it, and then make that judgment. It's just a thought.
Thanks for the tips. So I also mentioned in the intro that you are also the author of the book of the same name, right? MobProgramming. So where can we get your book?
Yeah, it's available in electronic form. We've more or less completed it just a few months ago. Even though I wrote it in 2016 with my friend Kevin Meadows, we put it in LeanPub, so you can buy it online. It's only available as an electronically delivered book. That's LeanPub. So you can make a easy link for that if you just go LeanPub/MobProgramming, I think. LeanPub.com/MobProgramming. You'll be able to find it.
All right. Thank you. Is there any news or anything you would like to share before we quit? Or
well, I would love to hear from people who are learning mob programming and having success with it or problems with it. And I'm always paying attention to Twitter, and I try to respond to anybody who reaches out to me there. My name there is just Woody Zuill, so you can find me pretty easy. So there you go. Also, you can find talks I've given in YouTube. And you can easily find other talks people have given on mob programming. We, I think, originated the idea, or at least were one of the early originators of this idea. But there are many people who have done things similar, and there's a lot of people who are sharing what their experiences have been. So yeah, it's easy to get more info.
All right. I'll put all the links in the notes that comes with this episode. All right. Thank you very much today for you coming, Woody. And it was really a very good to chat with you. Have a good day.
Oh, well, it was my pleasure. Thank you so much. And you did such a good job. It just made it so easy for me. Let me know anytime you want to talk.
All right. Thank you.